Okay. Hey there, this is Team 4666, the Locomotives, for First Tech Challenge, and we're here testing our newest addition to our manipulator. That is what we're calling a foot. That's an acronym for Flip Up Thingy. And this little guy basically will support the crates as we lift them up, and that will allow us to stack more and more crates.
Compile the data and we'll start the program.
Okay. We are running.
Alright.
Here we go.
So here's our arms, and they're powered by the servo right here. And this is our foot right here, and basically what we'll do is we'll pick up stacks of crates and rest it on this thing. So we'll
Officially titled the foot.
Yep, officially titled. So move into position.
Look at
It's
that.
going too fast, actually.
Yeah, well, we have a fully charged battery, but look how smooth.
So
Let's try to make a crate stack here. Nope.
this
Down a little more. Alright. Back. Okay. Okay. Still getting the controls down. Okay. A lot of power in this thing, huh?
Yep.
Crazy when you have a fully charged battery. That's how we should do all our tests, though.
And we want to flip it, so
Always have it on
here.
Helps a lot in autonomous mode, too. Okay. Boom! Look at that.
And then
That is cool. That is a bright crate.
ready to crate. So then stacked it. Then we need another one.
Okay. I'm just gonna keep this a little closer to you to drive this far.
Because right now we don't want to drive around too much because we want to program something called torque vectoring.
Oh,
Yeah.
Kind
That-
of naming a bunch of things.
And that will allow us to drive it without any with four-wheel drive without any extra strain on the frame and the motor and such. So I'm going to lift it up.
Oh, here we go. Oh, this is gonna be good. Okay. Maybe gently. There you go. I think you got it.
Boom! There we have a stack. So now I'm going to do the official test of the foot.
Oh boy.
See if
First
it-
test. Sorry. Go ahead.
Test if it actually works.
Okay. Stop. Oh, it looks like this is about to work too. Okay. Yeah. We'll restack those crates and.
So I'm going to do another test. It just wasn't running it correctly, so I'll try that again.
For the sake of time.
Yes. And
Not that we can't stack these crates all day long.
yes. Well, it's not the best thing for our motors, but
What? Sorry. There we go. Fixed it.
all right. I was wondering why the program wasn't running at all.
Yeah, that would be a program error, but
Yeah.
no problem. Okay, I'll stack those one more time for you. I think it's just a matter of stopping it on time. So,
Okay.
oops, let's lift the arm up. There we go. Okay.
Test number 3. This time I'm
Okay.
a little slower. Actually,
Just stop it early, I guess. And there you go, right there.
grabbing it.
Okay, and lift it and just, okay, now. Perfect.
Yeah.
But it's not high enough, so we can put the, So what are we observing here? What's the problem?
I think it's too far, so when bringing it up, it's pushing against us. Oh, gotta change the position of it, bring it up a little higher.
A little higher. Okay.
Or a little steeper of an angle. So
Steeper an angle.
not steeper, excuse me.
More
Shallow.
Okay, a flatter angle.
Okay.
Here.
So if you manually set it to 60.
Okay, I will manually set to 60. 47. No, that's 90. Hold on. Here comes 60. kind of a very slow change. About 60. Okay, there you go. Now it's 60.
Grab it.
Okay. Go! Okay, that's not steep enough. Okay, what happened here? It's not backed by anything, that's a problem.
Yeah, it rested too close, too low.
So maybe it's an X position problem? Position horizontal.
Oh, dang it.
Uh-oh. Did we lose our knot?
Yep, we lost a knot.
So that knot tying book did not help us.
No, because we only applied that knot to this spool,
Okay,
not to the arm.
let's apply the knot to the arm too.
Well, that knot wouldn't help in that situation, because it was a.
It was a spooling knot. Okay, you can't actually unspool that.
Yeah.
So we would have to just.
So
We could power off the robot for a moment and redo it if we want.
okay. Well, I can just here. I'll manually do it.
Okay. Oh, careful, be careful. Careful. You don't want to not. You want to be very careful touching a motor. It's live and powered. I'll suspend the program for a second for you.
Alright, I'll plug in.
There you go. Yeah, I just don't want to.
Make anything.
Oh, don't unwind it though, because it's still powered. It's still powered.
It's not.
Oh, okay. Yeah, he's. See how smart that he is? He just like grabs it and does everything on his own, and then plug that back in, and then I'll unsuspend the program.
Yep. Then we'll.
There we go. Okay, the program is resumed. Let's take the pressure off of this servo too. Don't want to waste all our battery on one servo.
You can let it down if you want to.
Okay, perfect.
Actually, probably not, because I have to.
Okay, I'm going to resuspend the program.
Just turn it off for now.
Okay, I'll just stop it. Okay, there we go. So one problem we're having here is just the power on this servo is not strong enough to. I mean, it's strong enough, but it's taking up a lot of power and it's putting a little bit of strain on the servo that we don't want to do, and we don't want to over torque these things. So. Okay, so let's find the coolest knot in the world to tie.
Oh, let's see.
Ah. Is that the best thing to do though? In that position?
For now, we'll have to get a longer spool, like this string is not long enough right now.
Oh, it's still wrapped around once. That's why. That probably is why it untied. It was just being stretched.
That should be better, hopefully.
But we'd have more leverage the farther out we go.
Oh no, it's not doing very good. Well, we'll figure out a better knot now, but that won't do for now.
That should hold it up. That should hold a few crates up, right? Okay.
Sure.
Program started again. Make sure everything's plugged in.
Alright.
And we will test. Okay.
Ready?
I'm ready.
Alright.
That's embarrassing. Oh, I know where that came from.
Let's go back to 40. Can you bring it back to 60?
Sure.
Actually, bring it to 55 or 50.
Good. That's 55.
Alright.
Okay, let's try it one more time. I'm noticing the problem with the X position of that. We should move it slightly to the left. No, with the foot, actually.
Okay. Or maybe just make it wider, just so we have a
Wider. There you go. So a little bit wide. There it goes. Perfect, perfect, perfect. Stop it. Stop
No,
it.
it's.
Oh, it's barely holding on.
Yeah, because it's holding on to. It's not working, so I'm just gonna lower it.
Okay. Is it successful? Oh, look at that. It's still stacked.
Yeah.
Oh, that's exciting. Okay. Here we go. I'm not ready to get stack.
Gonna try again. Grabbing it and lifting it up.
There it is. There it is. Okay.
All right.
Let's try to make a stack of 3. Now the foot is working. Look how beautiful that shape is. It's the perfect size.
And
Okay. Almost. No, lift it back up. This is so intense.
no!
Almost. Let's try it one more time.
Alright,
Okay.
bring it back.
Bring it back. Those nuts falling out of the robot are not actually attach to any bolts.
Yeah, because of
ever.
the C channel, there's less cavities where they fall into.
And then we can never find them because they're the exact same beautiful metallic.
Pass here real quick.
He's going to set the nuts on the table while he resumes control of the robot.
Alright, so test it again.
This is going to be a very fun video for our viewers.
Yep.
It just shows another fun engineering process that involves. So,
He doesn't have to make these wider because
okay. We're still on 55.
good.
Okay, so there's we probably want to back that with something. I'm going to try using the plates.
Alright.
And
We'll
then-
just finish up this video.
Okay.
I have this explanation of the robot, what we have it right now. So if you can bring the camera closer.
Okay.
So let's just if you can bring the camera closer.
If you want to explain the
So-
robot, I'll try to stack a crate. Maybe.
Yeah. If I can I have the camera real quick? So here's our 12-volt battery right here. Then our on-off switch here. You can see we have 3 motor controllers, motor and servo controllers. Those basically allow kind of splicing from the brain right here, which will wire to these 3 servo and motor controllers, which go to the 4 motors and 3 servos we have currently on the robot. This one right here controls the height of the arms. We have a servo right here,
You can sort of almost see it.
which powers the right arm. And then the 3rd servo right here powers the foot. And right here we have Samantha, which is basically a wireless communication between a computer and the robot. However, we haven't quite gotten that figured out yet, or not figured out, but just applied yet to this robot. So with this robot, we're just basically, our main idea is to take these crates and write them and stack them as we try to do. We still have some bugs to figure out with that. However, so far it's going very well.
This is a good test.
Yeah, and then
Okay.
future modifications will include trying to collect racquetballs and put them into the crates. So